Strategy only becomes executable reality when it is anchored to a schedule. Without one, a project remains stuck in the realm of vague intent, lacking the structure required to move from a goal to a finished deliverable. The data backing this up is severe. According to the Project Management Institute, 71 removing that operating system does not grant a team agility or freedom. It guarantees the project will derail under the weight of its own unmanaged dependencies. To build a schedule that holds, we use the 5-phase project schedule lifecycle. Phase 1 requires locking scope and goals before touching a calendar, preventing schedule drift. Phase 2 maps how tasks relate to establish a logical flow. Phase 3 connects that work to physical capacity, assigning exact time estimates, costs, and named owners. Phase 4 establishes a baseline to track live progress and catch deviation early. Finally, Phase 5 completes the feedback loop by comparing actuals against the baseline. This 5-part architecture provides the repeatable, mathematical logic required to organize complex work. It provides the framework for every move the project makes, from initiation to the final delivery. Execution begins with a work breakdown structure, or WBS. Every deliverable must be decomposed down to the individual work package level, so there is zero ambiguity about what needs to be built. Translated to a horizontal time axis, we map directional links between nodes. This reveals the critical path, the longest dependent chain dictating minimum project duration. If a single task here slips by 1 day, the final delivery date shifts late by a day. Mapping this sequence automatically surfaces bottlenecks before the project starts. You discover vendor dependencies that block downstream tasks during week 1 of planning instead of week 6 of execution. McKinsey data shows that it is 3 times cheaper to resolve risks discovered during this early scheduling phase than it is to fix them during live execution. Proper sequencing builds a risk detection network into the very geometry of the project, identifying points of failure before a single dollar is spent on execution. With the sequence mapped, we move to estimation. We assign exact time requirements, precise financial costs, and specifically named resources. This phase targets a primary failure mode, over-allocating the same individual to simultaneous competing tasks. This capacity chart illustrates the problem. On average, 40% of team members are over-allocated. We apply resource leveling. By staggering tasks through the schedule, we distribute the workload so no individual is allocated beyond 100% capacity. To protect the timeline, we use 3-point estimation, factoring optimistic, likely, and pessimistic scenarios, strictly for tasks sitting on the critical path. It is crucial to limit these buffers to the critical path. Overbuilding buffer into every single task across the project hides risk and obscures the true timeline, rather than actively managing it. Proper resource mapping removes the vague hope of availability. It creates a physically realistic distribution of human capacity across the timeline. Once the plan is leveled, it requires formal approval. This approved schedule becomes the baseline, a strict contract of time. Without a frozen baseline schedule, a project manager cannot measure progress. During execution, actual work is continuously compared against this ghosted background layer to see where reality deviates from the plan. Traditional reporting relies on narrative status updates, where teams simply state they are on track. Modern scheduling relies entirely on data-driven variance metrics. We track the Schedule Performance Index, or SPI. An SPI dropping below 1.0 triggers an immediate mathematical warning. Tracking these objective metrics against a strict baseline allows managers to detect slippage 2 to 3 weeks earlier than teams relying on subjective status reports. The baseline replaces subjective assurances with absolute quantitative reality. You know exactly where the project stands. Beyond the immediate team, the schedule acts as the core integration layer for cross-team and vendor handoffs. It dictates precisely when external inputs are required. When that visibility is missing, handoffs break silently. Forrester reports that 67% of project delays trace directly back to undocumented cross-team dependencies. Those delays compound because time is strictly tied to cost. Every task carries a resource cost, and every delay extends that burn rate. By tracking cost variance alongside the schedule, you generate real-time performance data. This tells you if late work is also burning excess budget, which dictates how you recover the timeline. According to Harvard Business Review, projects that lack an integrated schedule and budget management approach suffer a 45% average cost overrun. An undisciplined schedule silently erodes financial viability and destroys cross-functional trust. This brings us to Phase 5, closeout. A completed, variance-annotated schedule is one of the most valuable outputs of a finished project, often more valuable than the physical deliverable itself. By logging the actual durations and the root causes of delays, you create a repository of baseline data. This feeds directly into your organization's intelligence for future estimates. Consistently documenting this data yields a 34% improvement in overall estimation accuracy after just 3 completed projects. This dashboard displays what a healthy control system looks like in practice. Tracking a 0.94 recovering SPI, 87% of tasks on time, the exact status of 3 critical path tasks, and 6 days of float remaining. Build the schedule, baseline it, track it weekly. A project manager uses this data to lead the execution and stay ahead of the reporting cycle. Every moving part of a project requires a synchronization layer to function. The schedule is the definitive mechanism that converts chaos into coordinated delivery.